Math review, algebraic manipulation of logarithms. Here we have some examples. Because 2 to the power of 3 is 8. Therefore, the base 2 logarithm of 8 is 3. In general, the base b logarithm of b to the power of y is y. So over here, the base 2 logarithm of 2 to the power of 3 is simply 3. We can have different bases, but commonly we use a base of 2, a base of e, or a base of 10. Over here it says if you just see log x, you may assume it has a base of 10. It's not always true. In mastering chemistry, when you see log x, you may assume it has a base of 10, but in some other places, they may assume there's a base of e. Alright? But typically, a natural logarithm with a base of e is written as ln x. Alright? So when you see ln x, the base is e. When you see log x, for mastering chemistry, you may assume it has a base of 10, but in some other places, like this Wolfram alpha, they treat the logarithm logx as the natural logarithm. Now let's look at some equations. The logarithm of the product of a and b is the sum of log a plus log b. The logarithm of a divided by b is log a minus log b. The logarithm of a to the power of b is b times the logarithm of a. Alright, now let's tackle part A, the logarithm of 5x divided by 7. So we're going to have the logarithm of 5 plus the logarithm of x and minus the logarithm of 7. So right here, this is the correct answer. Now let's solve this problem. If 65 to the power of x is 26, what's the value of x? First, just by looking at this, we know x is smaller than 1. If x is 1, then 65 to the power of 1 is 65. Right? If x is larger than 1, then 65 to the power of x is going to be greater than 65. So x has to be smaller than 1, and x must be greater than 0, because 65 to the power of 0 is 1, and we have 26 here. Now let's calculate the value of x. What I usually do is I simply take the natural logarithm of both sides, and then we have x times the natural logarithm of 65 is equal to the natural logarithm of 26. So x is simply the natural logarithm of 26 divided by the natural logarithm of 65. So let's do this. I would say Wolfram alpha is very convenient when we tackle the homework problems, but it's also important for you to be able to use your own calculator to do this kind of calculations. Alright, so this is what we get. It's going to be 0.78. It's indeed less than 1, greater than 0, but I think it requires 3 digits to the right of the decimal point. So we're going to put 0 here, 0.780. We round it down here. Hopefully you can use your own calculator and Wolfram alpha to get the same answer. Alright? And you can double check your answer. You just have 65 raised to the power of 0.70. It should be roughly 26. Just by looking at this, I think it's going to be a little bit less than 26 because we rounded this number down. The natural logarithm behaves similarly to the base 10 logarithm. So we have this kind of equation. E to the power of ln x is x. The natural logarithm of e to the power of x is also x. So these two operations are opposite to each other. And now if ln x is 3.55, what's the value of x? Again, you can just use your calculator. And what I would do is I would have e to the power of ln(x) is equal to e to the power of 3.55. And also we notice e to the power of ln(x) is simply x. So x is e to the power of 3.55. So we have the answer here. It's 34.8. 2 sig figures, it's going to be 35. Another way to tackle this, if you do remember the value of e, this is the value of e, I think, and then you get the same answer, 35.